So, kind of leading on some of the people that you will probably have noticed from other panels that have been on before. But I think one of the things that came across yesterday, we had a little bit of a thing around research data management at some point, and why aren't the research data management people kind of involved at some point. We have actually Danielle on this panel, who was really kind of, apprehensive in some ways, because he's really sort of starting out and starting engaging and feeling her way around a bit. But I thought, actually, this is a really good route in, okay? And I think it's really important to hear some of those kind of research data management things that are going on. The idea kind of around this panel was really, what are the kind of acting parts that, have to come together in order to actually kind of bring about some sort of research computing equipment facility in general, people have been doing it a while, or just setting out, what are the kind of key principles that maybe are kind of underpinning that kind of design, or the sort of theme that runs through it, basic kind of fundamental things. So I will basically just run through the panel, let them all kind of introduce themselves, and maybe that's the one thing that we can kind of sort of think about in the first thing. Sort of, what is the setup that you have, and really what were the kind of core guiding principles that kind of explains what you've kind of ended up with. And so I'm going to first of all go over to Steve, I think, who's probably going to talk about a couple of different places because he's just moved roles. But so we'll start with Steve, and we've also got Mark Dixon, I think, online, but everyone will hopefully get a chance to introduce themselves and talk about their core philosophy.
Thanks, Owen. So I've obviously sat in the wrong seat going first. So I'm Steve Hindmarsh. I'm currently at the Norwich Bioscience Institute as Head of Research Computing, but this is only week 4, so I won't say so much about that one because obviously I'm still sort of getting my head into that one. Before that, I was at the Francis Crick Institute as Head of Scientific Computing for 4.5 years. Before that, I had a career in NERC CEH, doing lots of different roles actually within NERC and CEH. So in terms of I'll talk more about the setup at the Crick because I was obviously there for much longer, and the sort of guiding principles and sort of what we had there. So in essence, as on the sort of hardware side of things, we had a conventional sort of HPC, CPU, GPU clusters. We had a large amount of high performance storage, and then on the people side, to go with that, we had obviously an HPC team to run that and provide support to researchers. We also had an RSE team who were doing obviously software engineering, but also increasingly AI and machine learning. And then we had a sort of database and data services team to go with that. So we felt we had a really good mix of the sort of the core hardware and sort of the core facilities, and then all the skills wrapped around that. The guiding principles you asked about. So initially, obviously, I inherited a lot of the sort of structure and the systems. They'd been originally sized and sort of shaped to do what they thought what the legacy institutes needed that went to form the Crick. And then obviously over time that was shaped heavily by input from researchers. And I'm a firm believer in put the researchers first, listen to the researchers, and really take time to understand what they need, and then do the best you possibly can to meet that. So over time we shaped up. Obviously there were some things were obvious, as in adding more storage, more compute, but particularly on the skills side, which are all important. And we did move into new areas, and we made sure that we steered the RSE time firmly into what the research projects needed, rather than other projects that perhaps people thought they needed.
Thanks, Steve. Tom, do you want to say
Yeah, can do. Morning, everyone. So, some of you would have seen me yesterday, but for those that didn't, my name's Tom. I work for the Science and Technology Facilities Council, and I'm the leader of the CSPM core team. What does CSPM mean? It's a collaborative computational project for cryo-electron microscopy. So we take incredibly noisy two-dimensional images from an electron microscope of protein samples, and then we do 3D transformations to make beautiful high-resolution structures of proteins. And what the CCP tries to do is support all aspects of computational microscopy for life sciences. So we are a team of 8 people who pull together software contributions from 15 different external collaborating groups, put it together in a piece of software, and then give that software to our user community. And then we have a training program for providing skills and knowledge and dissemination so that the users know how to use this software properly and they use it in an optimum way. We also support large-scale facilities. We have lots of connections with the National Electron Microscopy Centre at Diamond, which is on the same campus that we're based, which is the Rutherford Appleton National Lab in Oxfordshire. And so, core principles, it's a good question. So I think we're a fairly new project, so we started in 2013, and it was a very timely place to set up a project in this area. There was a sort of seismic shift in technology that drove EM, so basically the detectors that go in the microscopes. There was a step change in technology, and there was a massive increase in using EM. And a huge investment of over 50 million in the UK alone on EM hardware. So we needed to be very pragmatic, and we needed to move very quickly because we needed to train this big community, and we also needed to try and provide the software that the community needed. So it was very important to make something reliable, that worked, that people could use, but at the same time to do it quickly. And for me at least, the kind of key thing that underpins all this is people. So the people within the group, to understand their strengths and make the most of them and make them feel happy and feel engaged. And then to understand the people and the needs of the people with all our key stakeholders. So the collaborating software developers that we work with, facility managers that we work with, and also the scientific researchers who use our software, so that we understand them and can meet their needs and do a good job for them.
Thanks, Tom. Mark, Parsons. We have 2 Marks on the panel. This could be interesting.
Thanks, Alan. So I'm Mark Parsons. I've got 2 jobs. One is Director of EPCC, and the other one is Director of Research Computing for EPSOC. But this panel, I've got my EPCC hat firmly on. So most of you will know EPCC. We were set up in 1990. I was around at the setup, but I went off and did a PhD, and then I came back in 94 as a programmer. My first job was working on parallelizing the Met Office weather model. And I think EPC's core principles kind of emerged over the first 10 years of our existence. And a key one at the start was to survive. And in some ways that's kind of lasted all the way through, because we've never been a centre, we've never been an institute. We've always been funded off individual grants. Each time we win a national service, it's through a procurement and a contract that lasts for 4 years. And that led to another of our core principles, that precariousness, which was we wanted to give people long-term jobs. I wanted to have a long-term job because I wanted to be able to get a mortgage. And initially, for the first 6 years, we were on rolling 6-month contracts, which you can't get a mortgage with. It's really difficult. So in 2000, we gave the university £1 million, and we gave everybody a permanent contract. So every EPC is permanently employed. And you can lose your job, you can be given notice just like any employee. We have to make people redundant. We've never done that. So a key principle really has been to give people long-term jobs, to ensure EPC survives, and also to run the best possible services we can for the UK science community.
Thanks. Danielle.
Yes, hello everyone. So as Alan mentioned, I'm a research data manager based in the Faculty of Biology, Medicine and Health at the University of Manchester. So I've been in this role for about 2 years now, and prior to that I was a researcher working in the lab. And so the IT infrastructure side of things is quite new to me, but I'm sort of very much bringing my research expertise into this role. So I work primarily with core facilities in the faculty. So these covered the electron microscopy, mass spectrometry, genomic technology, so there's 9 in total, and collectively they are the major data generators for the faculty, generating around a petabyte of data annually. So it was decided that that was probably a good place to start. So if we can tackle their RDM issues for the core facilities, then we can hopefully ripple that out to other departments and other teams within the university. So we started off this project about 2 years ago, and we have very clear sort of guiding principles. And one is that whatever we do as part of this project is replicable to other teams. So where possible, we avoid using sort of bespoke tools, and we look for open source tools as much as possible. We're also very much researcher focused, so I think me coming in with a research background has helped with that, so we can pull in researchers a lot of the time, and we take their input and feedback in everything we do, so in terms of designing infrastructure and what tools we look to use. But ultimately, we want to make sure that the data that we're generating in core facilities is findable, accessible, interoperable, and reusable, so according to these fair data principles that you may or may not have heard of, but they are very much at the top of our list of things to work towards.
Thanks very much, Danielle. Mark, Dixon, same question.
Hello, Manchester. Can you hear me?
Yes, we're good.
Oh, lovely. Fantastic. Hello, everybody. So I'm Mark Dixon. I'm head of research computing platforms in the Advanced Research Computing Unit at Durham University. And I've been the lead system support on various HPC systems for many years now, more than I cared to think of. First at UCL, where I put in their first central HPC machine, and I quickly moved off to Leeds, and then most recently made a move to Durham. And these systems that I've been involved with includes all the N8 systems so far, BEAD and its predecessor, Polaris. Now, at Durham, Durham's doing something interesting. So it's realised that there are a whole bunch of people across the institution doing useful things supporting research, and that its IT department may not be the best place to centralise that. So what it's decided to embark upon is a dispersed model where the IT department underpins everything, but then large research groups or departments providing their own facilities can coexist and build on top of that. And advanced research computing is one such one of these. It mainly consists of 2 groups: the research software engineering team, which I think we've heard from earlier in the event, and also the research computing platforms team, which I'm the head of. And this team is relatively new. It's been going for about 2.5 years now, and we're up to we've finally got to about 2.5 FTE, which I'm most grateful for. And its current focus is mainly on HPC, although one of our number holds a joint post doing some good work in that department. And with that, we provide user and system support for our local HPC machine, Hampton, where we inherited a 5,000 core machine, and we're currently migrating our users to a replacement 15,000 core machine. And we provide the system support for BEAD. So I think the question was about guiding core guiding principles. I'm going to indulge myself now and lean into my systems background and talk about that angle. And it's quite simple, really, to state that there are 3 main principles. First is to make things right. And by right, I'm talking about adjectives such as stable and secure and consistent, because the best case scenario where you don't get this right is people get frustrated and go elsewhere. And the worst case scenario is people don't notice that all their answers are wrong and all their efforts are for naught. This is more difficult than you might imagine, as people who have attempted it will know, particularly with HPC machines or research computing in general at the cutting edge. And sometimes, with the best efforts in the world, the technology does let you down and you can't actually make it stable. In which case, you start busily trying to hide the faults where they won't hurt anyone. So moving on from that, so aim one's like the most important. It's like number one. That's what you do. Aim number two is to make things easy. We've got to make these machines usable, and that could be as simple as doing things like getting rid of pointless boiler codes in scripts that people have to write. But fundamentally, what users do on the system shouldn't be in aid of the system. It should be in aid of the user expressing their choice on how they're doing their research. And the idea is to make that choice as flexible as helpful, and to remove as much friction as possible in getting the job done. Although it's of course really handy to leave a little bit of friction in where to persuade people not to do sort of bad things that kind of contravene laws of physics and networking and things like that, and moving huge amounts of data around from an institutional storage system into compute nodes, and so all those costly cycles are set there doing nothing for most of the time. And then once we've got those two simple matters out of the way, the third sort of least important one in my list, which might seem odd to some, but I consider it the least, is make it fast. That's what you do once you've got all the other stuff sorted out. And by that, a lot of it can be about buying the right technologies to balance against the problems you know that you have, because you really don't want to spend huge amounts of money on an interconnect you don't need, or storage performance that isn't necessary for your particular situation. It also involves paying attention to detail and providing sensible defaults, so the system kind of does the right thing without the user really having to think about it. At least if they do think about it, they can make their choices to that are good for them. And that generally means exposing performance enhancing choices to advanced users. But the most interesting work I find is where these aims overlap, particularly with the making it easy with one of the other two. And I think that dovetails quite well with Alan's opening session on Monday about the whole balance between people and things, and technology and research, and how research computing sits in the middle and tries to strike a balance with all of them. And I think I've gone on for far too long now, so I'll hand back to Alan.
Okay, great. Looking around the room just in case there's any, or online if there's anything that's going on before I move on. Cool. Okay, I think what would be kind of interesting to explore a little bit is just kind of, we've talked a lot about the people, I guess, that are involved in these operations, and so maybe through kind of examples where maybe this has happened. To what extent are people just kind of fulfilling a shopping list, right, that people come to with requirements, and to what extent are the people within the research computing operations actually kind of really part of the solution in terms of determining what it will be that actually then enables that next generation of thing? Maybe back to you, Steve, maybe around the kind of stuff that Crick did over COVID or whatever. I'd be interested. What is the role of the research technology professional in that kind of enablement?
So really strong. I think that fundamentally our role is, a lot of it is kind of what's possible and what works well. So we need to work with researchers to understand what they need to facilitate their research, and then I see it as kind of our job to then translate that into, well, how can we actually help you with that? What's possible? And what we think will actually work. There's obviously all sorts of things that are theoretically possible that you probably wouldn't want to bring into a university or a research institution. So that kind of a more prosaic example would be something like with the GPU cluster. Researchers have been saying that we need GPUs for both for structural biology, cryo-EM reconstructions, and obviously sort of to move more into machine learning. And then we had a strong role in terms of scoping out what that actually looked like, and that was much more of a sort of conventional process of understanding what are the options out there, how many, what's the optimum number of GPUs to have in a server, and all those sorts of things. And you mentioned the COVID example, so with without going, I could talk a lot more about this, as some of you will know already. But so early 2020, the CRIC put together a COVID PCR testing pipeline from scratch when all the sort of national testing capacity didn't exist or was drying up due to lack of reagents. That was a completely different process. That was very, very. So I and my team were kind of in the middle of that, trying to piece together. So in terms of the whole sort of testing process, there were lots of steps along the sort of pipeline from one end to the other, and my team were in the middle of trying to join everything up. So that was very much a case of moving parts everywhere while the individual steps were all sort of settling on something that worked, and we were the people in the middle working out how to actually piece that together, and how to get a flow that worked from one end to the other. So we knew that the sample that came in matched the result that went out and was tracked every step along the way. So that was a very, very, it was a good example of the process, but in a very, very dynamic and intense, initially a short period of time to sort of get the thing set up, and then we went into sort of more of the normal kind of steps of sort of iteration. So this thing's basically working. How do we then make it work better? How do we adapt to new requirements? How do we bring in other sample data sources and these sorts of things? So but that was quite a good example of something in a very, very intense. I guess it felt like a startup company, I guess, and having to do something very quickly to get something together, which we then spent time evolving and sort of getting working really well over much longer.
And maybe in terms of research computing professionals, sort of those attributes, what did those kind of the powers of persuasion in the team, what did they kind of look like, right? In terms of being able to maybe this is the way that we need to do this or whatever. How did that work out in this sort of very crazy situation?
So in that position, the powers of persuasion were about being respected for our areas of expertise. So people had to, again, because it was so fast moving and everything was in flux, and that was a very, very crazy time. We needed to be able to very quickly cut through and say, actually, this is what's possible. This is what we need. This is how we do things. So this is, but also who do we need to talk to? The whole setup was only possible because we worked very closely with one of the commercial testing labs that were linked to UCLH, which conveniently were just down the road. So we were able to learn a lot from them as well. So I think it's having that. If we'd come from a position of not having that trust and sort of recognised expertise beforehand, we might not even have been in the room anyway. But also, if we had suggested things that maybe at times would make things more difficult for other people, but we could see that was the only way of getting this thing working from one end to the other. So it helped massively, and was probably only possible because we'd already earned that respect, but both within the researchers and within in sort of with senior management as well. And I think onto that point, I think it's critically important if you want to influence choices of technologies and skills and directions. You have to, earning trust is critical. So you have to earn that respect and trust in that what you're talking about, but also that you've got your researchers, you understand your researchers' requirements, but also you have to influence upwards as well. So there's no point being in the corner saying this is what we should do if you can't actually kind of map that into what your institution, so how that works and what they can afford and things. So being able to influence upwards as well, and show that you can work within sort of the financial constraints and all those other sorts of security constraints and all other sorts of things. It is that sort of being able to represent both the researchers and the interests of the institute, and bring them together in a way that you can demonstrate that you know what you're talking about, and you can add value.
Thanks, Steve. Danielle, do you want to comment on this one a little bit?
Yes. So I can jump in on this. So, as I said, I started in this role 2 years ago without any IT background, really. So we've been heavily reliant on research technology professionals at the university and the research IT team to help us design our infrastructure. So the basic idea that we have is the 9 core facilities will use a centralized shared infrastructure for data storage, local data storage and compute. And ultimately that will then integrate with the university-wide data storage infrastructure. And so it's been crucial for us really to have the expertise from research IT. And this was recognised by the faculty, and we actually pay for half an FTE now in the research IT team. And not only did they come with the sort of the design ideas, but they also understand, fortunately, they understand the research environment themselves. So they came with sort of sensible systems that fit with the researchers. And as I said before, it's really important for us that whatever we do in core facilities isn't isolated. We want to make sure that we're integrating with the university-wide infrastructure, and therefore it was crucial that we worked with them in order to make that happen. The other thing is that before we started this project, the core facilities would handle their data separately. So we'd have 9 core facilities, each doing very different things with their data, which created a confusing environment for the researchers. And with that, each core facility was relying on a few individual technically savvy individuals to actually support these systems that they had in place, which was a major problem when somebody left, because they often didn't document it, and somebody would leave and then the facility would be sort of in limbo. So now that we're shifting over to this centralised system that's managed by the research IT team, we can have this documentation and this long-term support that we really need.
Thanks so much. Mark, do you want to just come in, maybe around the whole influencing, of kind of how you've seen kind of research technology professionals, kind of win people over maybe, or like influence the sort of direction of travel beyond maybe a preconceived idea about what a solution should look like or whatever, because clearly you've kind of been at the cutting edge of a lot of things in EPCC, and there's probably many examples, right?
So I think actually this is really difficult at times, and I think at Edinburgh, and I guess this is true of many institutions, academic groups will quite often put a little bit of money for a bit of equipment on a grant, and they will just suddenly appear with this, and they're terribly pleased with themselves. And I call them, and this is very rude to all the geographers in the room, I call them geographers bearing gifts. And it's the most common thing at the moment is somebody gets a DGX1 or a DGX2 on a grant, and they are very excited by this, but they've not thought about the storage, where it'll be hosted, just nothing about it. And you don't want to be Mr. Negative or Mrs. Negative, but you do think, oh God, how are we going to integrate this into anything? And what we've done over the last few years is actually to try and gently steer people away from doing that for the first time. And we got money to build a data infrastructure for the local region through a city deal. And I took a building block approach with that, which I think has worked really well. So we didn't do what people tend to. They get 10, 20, 30 million pounds and they buy an infrastructure. We did a procurement which had a set of building blocks. So 3 types of VM server, large, medium, and small, a GPU server, 3 different types of storage, hot, warm, and cold, broken down in the middle in warm to various different types of cloudy type storage. And we bought a little bit of everything to start. And since then, when people want something, we just buy a bit more, because we didn't want to impose our view of what a data infrastructure would look like. We wanted to meet the demand that's coming from the researchers and actually the companies and the public bodies in Edinburgh that use it. And that's worked quite well. We've tried to stay ahead of the game. It's really difficult, actually. I mean, everybody here who buys equipment will know that things that used to take 3 weeks to arrive are taking 6 months or 9 months to arrive at the moment. And it's not really talked about that much, but it's really making planning and delivering infrastructure really, really difficult. But that's basically what we've done. And I think it's we've been lucky that we had the money to do the initial building block contract. But actually, I do like this model now. It's worked really, really well for us, actually. And it's allowed the academics who would have put a server on a grant for us to say, well, just buy it off the catalogue we have. And so we end up with a set of infrastructure that is all by one manufacturer. It's much easier to maintain and much easier to manage. I like it as a model.
Okay, thank you. Shall we go to Mark Dixon this time? Just break things up a bit.
Hello again. So I think I'd just like to echo what people have been saying about trust. All this flows from mutual trust between the academics and the research IT profession. And that only comes from working in partnership for a period of time, in my experience. We are in a hugely privileged position to live vicariously through the researchers using our services. It's wonderful. We watch what they do. It's a bit creepy. We help them with their problems. We talk to them about the research, and that does put us in an excellent position to keep track of the needs we hear about, and to try and reflect them back at the time that makes most sense. And quite often we can work. If in the case of a system that you keep on refreshing every now and then, you can work many of them into the design without spending money, even only in the proof of principle stage. So it's you can sort of sneakily do a lot of influencing by presenting as a fait accompli. Just here are problems that you didn't necessarily realize that you had, but and here's some solutions. Thank you.
Thanks, Mark. I think it's really interesting, this trust thing, and what went through my head is this whole move, from, when I started, I did that whole many, over a decade in the University of Leeds, all gradually building this reputation, trust, and I didn't realise that, you kind of build this kind of political capital and all these things, move jobs to Durham, and it was like, okay, I forgot there was just nothing, right? I had to start from zero, right? And it was worse than starting from zero, because you had to kind of get rid of all the kind of preconceptions and all these various things that have kind of built up over the years that you didn't even realize existed until you got there. And, I was flown in by management, so I was evil, right? And so I spent about 2 years just trying to prove that I was not evil. It's just crazy. Anyway, Tom.
I guess one thing I'd say about this, it's about trust and building relationships. On the Harwell campus, there's various different facilities and faculties, and people wear different badges and belong to different organisations. And I was very fortunate that my counterpart at Diamond, who was supporting the microscopy centre there, and I had this same feeling about this, that these badges and names were more or less irrelevant, and at our sort of small local team level, we were just a group of scientists and programmers who were trying to do something useful, and we made a promise to ourselves that we would ignore badges and just work together, and that was really, really useful, actually, and it was mutually beneficial. So they were very supportive of what we were doing, and they used our software. And equally, we helped them when, for example, they were short-staffed and they needed someone to effectively sysadmin their microscopy software. And so we did that without any hassles, and that was really useful. And it's like you were saying, Alan. It's building those local connections and building trust by sometimes doing the less glamorous, less exciting things, but being really useful and really helpful.
Thanks, Tom. Marion, is there something that's come in?
Yeah, there's a question in the chat, and I don't know whether this is actually contradicting this whole like slowly building up trust thing, because JD was asking whether there are any thoughts on using agile methods for research environments, as we are talking about ways of working better. Has anyone given it a go?
Yeah, so we use agile quite a lot, and when it's done well, it's really good. When it's done badly, it's absolutely chaotic. And there are some people that we've worked with that come in from government, shall we say, Scottish government, who think it's just going to solve all their problems, and it doesn't. So I think it's absolutely got a place. It's a really good way of developing software quickly, but that doesn't mean you sacrifice the design part of agile just because you want to do something quickly, in my experience.
I think I can second that as well. I've worked on sort of different projects where we've used Agile. I think where if you have is it the Scrum Master who's in charge and they're really, they know what they're doing and they have that authority, then it can work really well. But without that, it can be a nightmare.
I'm not convinced that civil servants make good Scrum.
Yeah.
Okay, Simon, a microphone.
Yeah, I would comment on that too. Adopting a particular working method from another discipline is not always the best thing to do. So I would say pick the good bits from Agile and ITIL and all those other things, and just apply in a research context. You need to have flexibility and you need to listen to your users. So combine the best of those things with common sense and listening to your users, and I think that's a kind of good recipe for a nice cake.
So there's a nice label to put on that to help us remember it. Adopt and adapt is a phrase that you often hear in the context of agile methodology development, and remembering that the process serves you, not you the process, which is sometimes hard to remind some of our colleagues who are professional knowers about process. But adopt and adapt is always the best way to bring in any of these things.
Okay, so maybe let's talk about kind of almost planning, right? And sort of what is this kind of window of like what you kind of think about, right, in doing. Maybe come to Mark Parsons first about, in terms of EPC, its setup, hosting Archer 2, those things. What did you start thinking about a long time ago, and what did you really thinking like really recent? So what are sort of the long-term kind of things you think about and the short-term things you think about, and how restricted are you because of some random decision that got made 20 years ago?
So the first bit of EPC history, so the 1990s, was terribly exciting. We were all young, and we all thought we were masters of the universe and we could just deliver anything at all. And largely it was chaos. And we were often late on projects, not so much on the service provision, and systems were much simpler in those days, but largely on sort of software development projects, we were repeatedly late. We became quite experts and we were repeatedly late. And so towards the end of the 90s, we started formalizing how we ran projects quite a lot. And we went through quite a boring phase where we used Prince 2, and we're all proud about that. In the end, what we did was we used the useful bits of that process. And nowadays, it's quite formal, but not everybody is constrained by that formality. And what I mean is we've so many different sources of funding. So there's 120 staff, and we've got about 85, 90 sources of funding at any one time coming in. And if you work at EPCC, you get a schedule which is updated online every week or every fortnight by the planning team. And that says you're going to spend 20% on this project, 40% on this one, and 30% of that on that one. And you manage your own time, and some people just religiously stick to their schedule. They do that, and they come in and they go away at 5 o'clock or whatever. Others do their schedule, and then they just get on with their other stuff that they want to do. And they're not stopped from doing that. So we've found a nice balance, I think, actually, of dealing with, in any organisation you have very different types of staff, and some people really are just 9-to-5ers, and they're incredibly effective in that 9 to 5 period. Others work, I can't stop them working, they just work all the time. And you have to, and this is maybe what a mature organisation ends up being actually, you have to find a way of accommodating both those types of people successfully, without having one side trying to dominate the other, and that's the tricky bit actually. But it's I think generally we've got the balance right. I hope.
Okay. I'm sure I saw a microphone being. Was it Pastor James, or was you just hanging on to it? No, that's all right. Cool. All right. Okay. It's going the other way. Tom, do you want to come in around that?
Yeah, I came across something interesting the other day, and it's that you can, there's an idea in philosophy that you can break every task into 3 categories. So you're either creating something, destroying something, or maintaining something. And I think you can use that to reflect on operations, in software development or hardware development. And it's always useful to think about how each one of those 3 categories affects or fits to a particular scenario. Do you want to rip something up and start it again, or do you want to maintain it and adapt and adopt it, as James mentioned? Or do you want to create something new? And then I think in terms of how timescales, sort of decisions made in the past affect things, decisions that we've made well are picking collaborators carefully and working with good people. Decisions that didn't go, or went a different way than anticipated. Some of the software tools we wrote in the early days, we made the mistake of thinking that they were sort of prototypes and that they would have a short shelf life. But they once they become used, then they can last much longer than was anticipated originally. And so we're more careful now with planning for that in advance.
Thank you. Danielle?
Yeah, so planning is a really difficult one actually in core facilities, because we're working with a lot of moving targets, it feels. So we initially set out with the idea that we would have this centralised infrastructure for core facilities, and we are constantly going back and reviewing, how feasible and realistic is this, because each core facility works in a very different way. And the demands are very different. So you'll have one group, for instance, that'll produce a terabyte of data in the space of a year, and another group that will produce a terabyte of data in a day. So you have to adapt this infrastructure and make sure that it's divvied up and used fairly between each of the core facilities. So that's been challenging politically, I think, to make sure that we're doing that in the fairest way. But I think ultimately we still want to sort of stick with that model. The other sort of decision that we made early on was that we would try and avoid bespoke software and tools and scripting as much as possible. And I'm quite pleased actually how well we've done with that so far. But ultimately, we can't do that completely. We do have to go to bespoke for some aspects of it. But yeah, the challenges is sort of getting people to work together, I think, with this. And that's become more of an issue sort of now as a result of those decisions that we made early on of getting core facilities centralised. So, I mean, things like just having a standard folder structure or file naming convention, you'd think that was straightforward, but it's really, really not. So those are the challenges that we've got as a result of these decisions that we made early on, but we're finding sort of workarounds to make that happen.
Thank you. Mark Dixon?
Hello, right. So as we're such a new unit at Durham University, we're in a way that we're fortunate that we've had to rethink everything in a sense, because we didn't exist a few years ago. Having said that, we have benefited from being asked to kind of refresh existing services at the university, and so that's given a good framework rather than a blank piece of paper, which it could be pretty hard. And the in terms of how much of what you're able to do might be enabled or restricted by decisions years ago, I think it's probably no surprise to people that what isn't hard is changing the technology, and then what is hard is changing or influencing user behaviour, how people actually use the system. And I think I'll leave it there.
Okay, Steve.
So I say we as any team, you're kind of, it's stating the obvious, but you're nothing without the right people, and the people are absolutely key to it. Obviously, you need everything else to go around that as well. So I think in terms of my experience, some of the decisions that were made that had the longest and the biggest benefits were sort of recruitment decisions. In many cases, that happened before I've joined an organisation, both at the CRIC and the MBI. So I would say the team leads I had at the CRIC were probably were incredibly influential in terms of the level of service we could provide and how that service could evolve. And I think they also around that some of the sort of team structures. For me, I work quite organically with those things. I know some people come in and they decide to just, okay, I'm sure we've all worked with people like that, and some of us are people like that. That's not a wrong way of doing it, but some people come in and they say, okay, yeah, we're going to change this around, and a big new team structure. For me, I prefer to sort of, if you like, swim in the structure a bit to really get a feel for what's working well, where the skills are, and probably to the slight occasional frustration of my teams, I'm also quite happy to have some fuzzy boundaries. So an example of that, at the CRIC one, we used to have 4 teams, and we had a sort of software development effort was spread across 2. So we had a web team, a digital development team, and we had a separate, it wasn't called that, but effectively an RSE team. And over time, we had some really good recruits in the new people joined the digital team on the website, who so one of which had a really strong interest in machine learning, and that's something that actually could have been difficult. But I said, no, that's great. Let's encourage that interest, and he got involved in some projects, and actually it soon became clear that the right thing to do was to merge those 2 teams. And over time, in the end, our head of HPC left, and then we had a little bit of a juggle around, and the sort of a really nice new structure. If you like, from the outside, it kind of fell out of nothing. But actually, that had been a long time in the planning. But because it was done more organically, everyone was really happy about it, and it worked incredibly well. So that's sort of thinking about the people side. On the technical side, for me, pragmatically, some of the sort of the part of it that has the longest lead time is probably storage, because that's kind of fundamental to everything. And when you've got a lot of it, it takes a long time to move it to anything else. So that's probably, I inherited the storage system when I joined the CRIC, which worked very well, but that probably had most of my time while I was there, well, not most of my time, but a bigger chunk of time than the other technology parts in terms of working out what was going to come next. And of course, there's always the as we just talked about already, the sort of supply chain issues in terms of things taking a long time. So the system that should have been delivered by this week is actually going to be sometime in June, I think. But that's a fact of life for all of us at the moment.
Marion.
Here's a question in the chat from James. I'd be keen on hearing about any examples where an established process has been found to be suboptimal and been replaced with something better. How did you avoid friction and communication and communicate these changes to the staff and users without frustration?
Would anyone like to take that one?
We've had sort of suboptimal processes, but usually it's the users coming to us asking for a change, not us inflicting it on them. So,
Yeah, I mean, because normally it's a bit like this kind of, the processes need to serve the outcome rather than to serve the process, right? I mean, this is why our processes are meant to make our lives easier, right? But
So
I think that's an important point, just to follow up on this, is I think, and I definitely have my EPCC hat on, I'm going to say, I think EPSC don't communicate particularly well with their users. I regularly get complaints from people in our church too that the messages given out to them by our help desk are uninformative. But we're sent the text for that by EPSC. We just have to do what we're told, and we just send it out. We're not allowed to say anything more. I find that incredibly frustrating because as a user, I'm actually quite interested in what's gone wrong with the system. You know, I'd like to understand, if I'm not got a computer for 2 days, it is interesting to know that such and such caught fire or whatever, and somebody's fixing it, just generally. And I think that we do not communicate well with users at times, and that's a frustration. And I see that in a number of different ways.
It reminds me, I was on the train coming here, and there was a service announcement saying, sorry, this train is late due to an unspecified problem.
Excellent.
And if they just said there were leaves on the line, the train was broken down, people are much more understanding.
Exactly.
Marion, do you want to, you've got the mic at the moment, and then pass to Mark.
Yeah, I just wanted to read out the additional comments or the problem that James is facing at the moment. I know that our next HPC is not going to be peering onto our shared storage areas, which is going to annoy users. We've had issues with them using NFS-mounted stores equals low performance, so we want to motivate them to use the higher performance storage. They are used to not needing to shuffle data around, so I expect people to get quite miffed.
Mark.
So on the communication side, there was something that the research computing team at Leicester started doing about 5 or 6 years ago, I think, which has really helped with that. And it's when the email comes round that says, this thing that you've been doing this way for ages is now going to change and it's being done this way from now on. It's actually broken down it's a very short but structured email that says, what's the background issue? What change is being made and how does it affect me? And that actually was a great way of doing it, because then people know it's not just telling you the thing is changing, it's saying there's a problem, you may never have noticed this problem, but this is where it's come from. This is how it's going to affect you. And that has, obviously people still get annoyed when they're in the severely affected group, but at least you've given them more information. Like Mark was saying, it's very annoying just to be told it's changing and we can't tell you why. So I think that helps to smooth difficult changes like that.
Simon?
Yeah, I would completely second that. And Mark's in a really difficult position if he can't explain why things are happening. All of our users are researchers, scientists, engineers. If they understand something, whatever it is, good or bad, they are much happier with it than not knowing. So I would say always explain what you're doing, why you're doing it, and what the benefit is or what the constraint is. It might mean you've got 10 times more storage. It might be that actually we've only got budget for this and you'll end up with storage that's too small for you to use. And the second thing I'd say is when you're doing transitions, make them a gradual process rather than a step change if you possibly can, because that means if you've got users who are in a difficult situation, you can maybe delay moving them until later on and give them time to adapt to the change that you're making or to finish what they're doing. So that's my decades of experience.
Thanks, Simon.
That's helpful.
Microphone's going backwards between. Okay, James.
Yeah, it was just to pick up on something Simon said. Yeah, okay. I think pilots are a great way for a big change. Like we in Leicester, again, when they were introducing multi-factor authentication, it was first piloted with a group of volunteer users so that you could actually see some of the problems. Then it was piloted with some users who'd already heard about it and raised potential issues. So it means that helps to smooth it as well. And it's the usual thing of having some early adopters who can help spread the message that actually it wasn't as bad as people expect.
You can speaking of pilots, you can get it wrong though. I was on a plane once where the front wheel wouldn't go up and it was vibrating a lot, and we didn't know what it was, and the pilot came on and said, I'm very sorry, but the front wheel won't come up. So we're going to do some quite quick shaky manoeuvres to see if we can make it come up. Now, that was fine. I accepted that. He told me that the plane was going to make some strange manoeuvres. However, he then said, if that doesn't work, we'll think about what to do next. And I thought, why have you said that? I didn't want to know that.
Okay. James?
So yeah, I'm really fascinated by this transparency in communicating our struggles to get failing systems back up with users' question. I was debating this with some enterprise IT colleagues a few weeks ago, where I very dogmatically went all the way over to the let's be totally transparent with our users. They're all engineers. They want to know exactly what's going wrong with this, and I'm trying to understand, because it's difficult for me, what the kind of where do the people who prefer to say that the train is late due to an unspecified problem, where are they coming from? What's kind of, their how does that mindset work? There was an argument that when we don't yet know what's broken, right, and we're going through the discovery process of fixing, and we don't have a time to fix yet, how do you communicate that? And are there ways in which we can sort of split the user community into those who are entertained and by hearing about our struggles with the machine, and those who just want to know when it'll be working again? Thank you very much. I definitely have no sympathy for the hiding your struggles from users because it's embarrassing to you side of the argument. Like, if you screwed up, you should be transparent about that. But I was persuaded by the having respect for your users' inbox numbers side of the argument to some extent when we went through that conversation. So largely I remain on the dogmatic, let's just be transparent about everything side of the argument. But I do think it's a fascinating one.
Thanks, James. I noticed Nicky's there with the microphone.
We're missing a volunteer this morning, so I'm just running at the moment and standing around like a big tree.
How long is this session? Is it?
Oh yeah, sorry. I got you got another quarter of an hour. Keep going, guys. Keep going.
Marvellous. Okay, so here's sort of another anything. No, great. So I guess one thing that is interesting, sort of developing the team and kind of sort of this kind of like. So when I worked within enterprise IT, there was a whole kind of buy not build kind of philosophy that came about. I mean, and in terms of the sort of the organisations represented here, to what extent do you go out and just buy solutions, and what extent do you basically take ownership of the solution and investing in people and technology and kind of bringing it together? And what's that balance within your kind of your area? Maybe Mark first of all online, and then we bring it back in the room.
Yeah, it's going first. Okay. So there is a temptation to leave it all to the experts, i.e. the vendors, particularly if it's something new that you've not done before, and that works well for some. But you can very rapidly become unstuck for various reasons, and I think for me the categories of reasons that there are problems broadly split between kind of commercial issues where the vendor may have spent all the support money and put it in the machine in the first place, and so you may not get a good level of attention later on. There may be technical issues if what you bought isn't actually such a good fit for you as you initially thought. And then there are other locality issues where you understand, where you realise that you understand your users' needs better than the vendor who you bought your solution from. And I find that the freedom of being able to understand and then innovate through the life of the service is a complete must, because ultimately you do have to live with it, and it is your reputation on the line. And you do run the risk of if a vendor moves on, you may not have built any in-house skills to cope with that. So one alternative is to own the design. and break it up and choose which elements to invest effort in developing skills with the staff. And these could be technology, things like interconnect, file systems, and batch schedulers. And then you could choose which elements to outsource. And then you kind of draw a line where that might be. You might be happy, just people manufacturing equipment for you. You might want kind of buy from a tier 1 vendor. You might want somebody to do all your cabling for you. You might want somebody to provide the software stack and then leave you to support the applications. But the trick is to find the balance that works for you and your environment, to try and get the best of both worlds and to keep your staff interested.
Thanks, Mark. Steve, do you want to around that?
Yeah, I think that's a really good approach, and I think for me, obviously there'd be building blocks that we would go out and buy. I think in terms of putting together a solution, I would always want to understand. I'd spent a long time actually talking to different vendors and sort of doing our own research and sort of working out how things fit together, what are likely good solutions for us, and then obviously we talk to vendors and we'd go out and buy probably the building blocks or maybe a sort of a solution that we've kind of worked very closely with them on to make sure it's fit for purpose. The other crucial thing for me, I've always felt very strongly about having as much knowledge as possible within my team. So I don't like black boxes that we know nothing about, even if obviously we want support contracts as well. We're not saying that we do everything in-house, but I would always want as much knowledge as possible, because even if someone else is doing the sort of the day-to-day sort of support, if you don't know what's happening within that black box, you're completely lost. And if something doesn't work as you expect to, you've got nowhere to go because you don't understand it. It's just something's not working. So I've always been a firm believer in my teams of having as much knowledge as possible of what's happening inside that box. So whether it's the whole solution or whether it's different components of it. I wouldn't want a sort of just a black box solution that drops and will solve all our problems, because it probably won't, but also when there is a problem, we won't even know how to approach it.
Yeah. Go on then, Mark.
Yeah, I was going to say I think that's critically important. We've just done an upgrade to Cirrus, our tier 2 system, and we have to get HPE in to do part of that work because there's a whole lot of drivers that we don't have access to. You can't download these drivers off the internet. They're HPE drivers, but if we just leave them to do it themselves, they'll leave us with a working system, which the next time we reboot it, probably won't boot for some reason. And what we found over the years is we have to work collaboratively with the vendor and get it to the point where we're happy that they can go, right? And that's not a bad thing. It's just they are always under pressure, and the people that they have working in these teams, be it Atos or HPE or whoever, have got a vast list of work to do. And they're under huge pressure to move on. The other thing as well is these people move around a lot, so you cannot guarantee that when it goes wrong in 3 months' time, the same person will come in. Many times we've had somebody come in and they'll go, oh, I wouldn't have done it like this, but then you're back to the start of the problem again.
Tom, do you want to say anything about?
We're principally a software development team, so historically everything has been in-house, but recently we've just had we've subcontracted out some work to an external group due to kind of funding and timing and resource constraints. And that's been really fun. But as we've just heard, part of the thing about that is it's key to avoid a black box. So we've had to work very closely with them, and we're in the process of handing over the code to make sure that all of the knowledge is transferred back internally so we can maintain it in the long term.
Danielle?
So we went out and bought a research data management tool. I'm a team of one, so we don't have the luxury of building our own tools, but also we kind of want to make sure that whatever tools we get are useful to across the university and not just for core facilities. So we settled on this tool, OSF, which is an open source tool that's not for profit, but you can contribute to their running costs effectively. It's sort of relatively cheap. And so we bought that, for core facilities, and we've worked closely with the library to make sure that that tool will be available across the university, so not just in core facilities. But there are aspects of it that we've had to tailor for our workloads that we want to do in core facilities. And to do that, we went back to the vendor and said, we would like this functionality. Can you build it for us? And they do have the option of actually paying developer time so that they can introduce these changes. And those changes will go into the core piece of software and be shared globally to anybody else who actually purchases this. We've also just sort of started a relationship with another provider, and it seems like that's going to be the same with them. So we've gone back with bespoke requirements, and they've said, oh, actually, no, this is probably useful to our other users as well, so they're going to build that into their software. So it seems that we're getting sort of bespoke without actually having to do anything bespoke ourselves. And those benefits hopefully are rippled across to other people too.
Thank you. Anything in the room? Simon.
Thank you. I'd like to echo that last point. It's not being bespoke, that's collaborating with your vendor.
Yes.
And that's a really good thing to do. Like you say, you benefit from that. The vendor benefits from it because they're putting something in their product that is really useful. And the chances are your colleagues in other institutions like yours will benefit as well if they have that product. And I'd also like to add something about procurement and the situations where you're buying a system and you tend to buy hardware, and procurement will push you to buy hardware. Things like services and software are a bit too fuzzy for procurement to deal with very well. But if you know that you're getting in a new piece of software, like a file system like Lustre, for example, if you haven't had it before, and you don't have expertise in your team, then you really need to plan ahead for that. And you need to budget for that. So that means either you get somebody extra in your team to look after that technology, or you arrange that that's included in the procurement and you have a very definite amount of support for that software in an ongoing fashion from your vendor. You can't just rely on it being an HPC contract and they'll help us out. It's like, we don't have Lustre expertise, therefore we want the vendor to provide that support for us for our system, and that will be 1 day a week or something like that. It's going to be way more than you think it will be. So planning ahead for that kind of thing, in particular the cost for it, is really important.
Thanks, Simon. Marion?
There's just one participant asking about the name of the open source RDM tool again.
Yeah, it's called OSF. It's
OSF.
an open science framework.
Thank you.
So I apparently have 1 minute, is Nikki's telling me. So anybody got anything else in the room? Or shall we? Yes.
Thank you. Yeah, just very quickly to kind of carry on from one of the things Danielle mentioned just then. So I'm here to represent the library that she mentioned as part of this piece of work with OSF. So yeah, I mean, it's just to emphasise that obviously we're really keen that in these situations that provides a great pilot for us, because it's a real life use of a tool or a platform to enable the core facility that Danielle works in to do this work. But at the same time, we get that perspective of how we can then think about working across the institution. You know, we're very, very focused on open research and open science. It gives us an ability to look at ways we could expand that into areas, including, you know, not just the typical scientific research that we do, but obviously into humanities as well. So we're very keen to carry on with that kind of work. And, you know, the emphasis for us is always on that collaborative work with colleagues who are able to do these pilots and pieces of work with us too.
Thank you very much. So I think this brings us probably to a reasonable close. So can we thank everybody who's participated here, everyone in the room, everyone online. Thank you, Mark, especially for Skyping in. Thank you very much, everyone.